Hey everyone, thank you so much for checking out my channel, Travel with a Twist. This week we are going to be talking about the different types of polycystic kidney disease, as well as how they are developed and caused in patients and the impact that that has. We'll also be talking about something I'm looking forward to after transplant, as well as my travel tip of the week. So in order to understand a little bit about this, we need to do a science lesson today. And this is in particular for all of my science nerds out there. I do want to preface that I have bachelor's degrees in human biology as well as medical lab science. And so I've done a lot of this type of coursework throughout my college career, as well as just wanting to learn more about my disease in general through great resources such as the Polycystic Kidney Disease Foundation. So I'll include their website in the description for more information. So in order to understand this a little better, we need to start with the basics. So every living thing is made of DNA. There are different segments of DNA called genes, and those encode for various traits, such as anything from eye color and hair color to different personality characteristics to even different disease types and variations based on mutations and things like that. The DNA segments and all the DNA is packaged into things called chromosomes. So typically each person has 46 chromosomes. There are different variations for that as well, which lead to different disease states. But in general, each person has 46 chromosomes. They inherit 23 from mom and 23 from dad. So essentially each person has two sets of 23 chromosomes. So there are two different types of chromosomes. There are sex chromosomes and autosomal chromosomes. So the sex chromosomes are inherited from your parents, one of each, and that determines your gender, either male or female. Then the other 22 that are inherited from each parent are known as autosomal chromosomes. And those are those are numbered chromosomes based on the size and the variation of each chromosome. And so polycystic kidney disease is an autosomal disease. And so that means that the disease genes are encoded on the autosomal or the numbered chromosomes as opposed to the sex chromosomes. So therefore, there's equal chance of both males and females developing this disease because it is impacted on the autosomal chromosomes and not specifically the sex chromosomes. So there are two different types of polycystic kidney disease. There's autosomal dominant polycystic kidney disease and then autosomal recessive. Just a little introduction about autosomal recessive. That is a little more rare just because the pattern is a recessive pattern. So what that means is that the person that's affected has to obtain an abnormal gene from both the mom and the dad in order to be affected. And so this occurs in about 1 in 25,000 children. It typically affects children most and can cause them to need kidney transplant at a really young age. But I do know that advances and things like that have really helped to improve the outcomes of this type of polycystic kidney disease. And so that's really great news. But I'm primarily going to specifically focus on autosomal dominant polycystic kidney disease because that's the variation that I have. It is also a more common variation of this disease. And so autosomal dominant means that there is one gene that is affected from mom or dad that impacts the child, and that is dominant over the other gene. And so you only need one of the abnormal genes to cause the disease in the children. And so a little demonstration I have for you. So I inherited this disease from my dad. And so like I said, you get a set of chromosomes from mom, a set of chromosomes from dad. And so dad will have an abnormal chromosome here and then a normal chromosome in his set. And mom will have two normal chromosomes. So this can also work the other way as well. But in my instance, my dad has it. And so Each child that they have then has a 50% chance of developing this disease, because dad can either pass along the abnormal gene to the child, or he can pass along the normal gene to the child. So in my case and my sister's case, my dad passed along his abnormal gene to me and my sister, and then we received a normal gene from my mom. And so we have one abnormal and one normal gene. Since this is a dominant inheritance, the abnormal gene essentially overrides the normal gene of the disease, and that will cause the polycystic kidney disease. And so each family has, with every child, a 50-50 chance of developing polycystic kidney disease. And so I have a diagram here as well, just kind of showing the visualization of that thing so you can see it a little better as far as how it is inherited. So there are two types of autosomal dominant polycystic kidney disease. There's type 1 and type 2, and those are based upon which genes are mutated or abnormal in the specific patient. And so type 1 typically experiences larger kidneys as well as an earlier onset of symptoms, and it's kind of known as the rapidly progressing variation because it will lead to end-stage renal disease and kidney failure usually earlier on than type 2. Type 2 is the more mild variation, and it will usually have a slower progression as well as delayed onset of symptoms. My family has type 1, and so it is more rapidly progressing. I was able to find this out through getting a genetic DNA test done through one of the trials that I was participating in. So you can kind of see here, I've got a picture of the results. It's really neat. It shows the type that I have. It also shows the specific genes that are affected as well as the specific type of mutations, and so they use that for entering in databases to help determine which patterns of inheritance are in different families, as well as just learn more about the disease in general. Each of the different abnormal genes, polycystic kidney disease 1 and 2, produce abnormal proteins. Then PKD, polycystic kidney disease 1 produces polycystin 1, and then PKD 2 produces polycystin 2. And so when those proteins are produced abnormally, that is what leads to the development of the cysts, because there's an abnormal function in the proteins which is used to produce the kidney tissue as well as control fluid secretion. And so that abnormality causes increased fluid secretion and leads to the development of the kidney cysts. So there's a little bit about the basics of kind of how I developed this disease. And my next topic I want to talk about is something I'm looking forward to after transplant, and that would just be, I think, the simple thing of being able to climb a set of stairs without getting winded. I've noticed that especially more recently, I walk up my flight of stairs at home, and by the time I'm done, I'm winded, I'm breathing heavily, my heart is racing fast, and my legs are burning like I just ran up a hill. And so it'll be really nice to be able to just walk up a set of stairs without feeling super fatigued and worn out. And then my tip of the day for traveling is just the importance of making sure you're taking medications on time. I know a lot of traveling, you can cross different time zones, and it messes up the time frames of when you're supposed to take your pills. What I usually do is I'll set alarms based on my home, when I take my pills at home. And so I'll remember to take them at those specific times with long flights or overnight flights, traveling days. And then there are also a lot of great apps out there that help manage medication time frames and accommodate with different time zone changes and stuff like that. So it's always just important to make sure you're taking your pills. And so going along with that is making sure that you're taking them on time and when you need to, especially after transplant, because there'll be a lot of different medications for specific times of the day. So thank you guys so much for checking out this week's video. And as always, please leave any comments or questions in the comment section and share, and we'll see you next week.